Hello, good morning. This is Nas from NB Network Lessons. Hope everyone's doing okay and in high spirits. Today, we're going to talk about mass and weight. We're going to solve a mass and weight problem under physics. So, here's the scenario. Okay, you are in a car and you are driving with a velocity of 110 kilometers per hour. So, you're going with a pretty good speed, 110 kilometers per hour, and all of a sudden something comes in front of you and you have to slam on your brakes. Okay, when you slam on your brakes, I hope you never have to do that in real life, but this is just a problem. So once you slam on the brake, what is the frictional force, which is basically in the opposite direction? This right here, F with subscript F, is in the opposite direction. What is that frictional force? That's what we need to find out. And then we also need to find out, after you just slam on the brake, obviously your car is going to slow down, right? What is your acceleration at that point? So let's see if we can solve that problem. Okay. So the given is the mass of this car, which is 1,750 kilograms. Frictional force is the 25% of the weight. So whatever the weight of the car is, the opposite force, the frictional force, is 25% of that. Okay. So uh, let's see if we can find out. First thing we're going to do is find out the frictional force. F and then subscript of F is equal to 0.25 into 1750 multiplied by 9.8 meters per second. Because if you think about it, weight, which is also equal to force, is equal to mg. Now weight is pulling the car downwards. Okay, so the gravity is acting downwards. So that's why I have 9.8 with a plus sign. And given is that the frictional force is 25% of the weight of the car. So then this is the frictional force. All right. Once you solve this, what you will notice is that this frictional force is equal to negative 4287.5 Newton. Now, why is this negative sign? Because if you have the orientation like this, right? If the force is in this direction, obviously this is going to be plus. If the force is on the opposite direction, you have to say it negative. That's the reason I say force subscript frictional force is equal to minus 4,287.5 newtons. Clear? So far, so good. Now, the next question is find the acceleration, which is right here. So, how do you find the acceleration? Well, we can use the Newton's second law of motion, which is basically force is equal to mass into acceleration. But in this particular case, we have to find the sum of the forces. Obviously, once you slam on the, once you're driving down, okay, and you have force basically which is pushing you, and then force which is resisting the motion. So you have to find the sum of the forces. So then the sign for sum is like this: S, F, which is a vector. Let's say this is x direction, is equal to mass and then acceleration in the x direction. Now the question is, once I slam on the brakes, okay, the only force which exists is the frictional force, which is pushing, which is basically stopping me. Frictional force in the opposite direction. So then there is only one force available. So then what I'm going to do is I'm going to say minus 4,287.5 is equal to m A, which is 1750 A. Mass is given right here, okay, times A. And once you solve this, my friends, the acceleration is going to be minus 4287.5. I'm doing some algebra, divided by 1750, and the answer you get is negative 2.45 meters per second square. Okay, so, and it makes sense, the acceleration is negative because we are basically de-accelerating. You go on and you're accelerating, all of a sudden you're slamming on the brakes, then you're slowing down. Your acceleration is, decreasing per second. So, my friends, I do have one more section to this. I'm going to come back and solve it in my next section. That question is, how many meters does the car travel after you slam on the brakes? Follow me on to the next section and I'll show you how that's done. Take care of yourself. Bye-bye.